So this is my program. There are 5 different classes. One class for priority queue. There are 4 classes for each sorting algorithm that we have to do. Okay, first of all, I created 5 different arrays. This array heap is the main array. The other 4 are just a copy of it. After this array heap is created, after the random numbers are generated, the other 4 arrays will copy, so that when we do the sorting algorithm, we will do from the start. Okay, right now I'm gonna explain from the main. First, it will call out this menu, just a simple menu. Press 1 for generate 9 heapified random numbers, 2 to enqueue, 3 to dequeue, 4 to 7 to do the sorting, and then now I'm gonna explain the class heap. So this function enqueue heap is just to when we want to insert something, I will put the element at the last index, and I will increase the size of the heap. Then for this function heapify heap enqueue, because in my program, after we enqueue each element, we have to heapify it. So for example, let's say we have a we have 9 over here, 8, 7, 5, 4, 3. So this is a heap. This is a priority queue. So let's say we want to enqueue element. Okay, before this, the size of the heap is 6. So plus right now we enqueuing 1 element, so it's now become 7. So we want to enqueue, let's say for example 10. And then in here, integer child heap is equal to size heap minus 1. Parent heap is equal to child heap minus 1 divided by 2. So let me give the index first. 0, 1, 2, 3, 4, 5, 6. So for the child heap size heap minus 1. So size heap 7 minus 1 is 6, so it's right over here. And then the parent heap, child heap minus 1 divided by 2. 6 minus 1, 5 divided by 2 is it's integer, so it's 2. So this while loop is used to heapify the element, so that this 10 here will be where it deserves to be. So the condition is, first the parent heap must be greater than or equal to 0, and the array heap of the parent must be less than the array heap of the child heap. So for example here, we have the parent heap, the index of the parent heap is 2, which is greater than 0, and then the value 7 here is less than 10, so we have to do we will be inside the while loop. And here integer temp is equal to array heap parent heap, array heap parent heap is equal to array heap child heap, and then the child heap will be equal to temp. So we declare temp which will be equal to the parent heap 7, and then the parent heap will be equal to the child heap. 7 over here will be equal to 10, and this 10 over here will take over the 10 value, so it will be 7. Next, we will update the index value of the parent heap and the child heap. Here the child heap will become the parent heap. The child heap, before this, the child heap the value is 6. Now we make it points here. Child heap is equal to 2, and then parent heap is equal to parent heap minus 1 divided by 2. Parent heap, before this it was 2, and then 2 minus 1 1 divided by 2 will be 0. So this right now is the parent heap, and since the parent heap is greater than or equal to 0, and the 9 over here is less than 10, so we are still inside the while loop, so we'll do the same thing. Temp will be equal to 9, the value here 9, and then the index 9 here will be 10, and then here will be 9. Copy back from the time value, and then we will update the value of the child heap and parent heap. So before this, child heap is over here, but now child heap is equal to parent heap. It will take now the child heap will be equal to 0. To calculate the value of the parent heap, so 0 minus 1, negative 1 divided by 2, negative 0.5, so 0. But since this is the last level, so we will not we will finish the while loop. So this is it, how we enqueue an element, and then I will explain the process of dequeuing an element. So the dequeue heap function here is just that we copy the value from the last element to the first element, and then we decrease the size of the heap. Okay. Let's use the same example that we just used right just now. Okay, let's say we want to dequeue. We'll take the value 7, we copy to the first index of element here, 7, and then we just decrease the size of the heap. So basically we will just ignore this part. Okay, right now size of the heap is 6. So let's get into the heap. After we do the dequeue, we need to heapify back the heap. So here parent heap is equal to 0, child left heap is equal to 2 times parent heap plus 1, child right heap is equal to 2 times parent heap plus 2. So it's basically right here, parent heap is equal to 0, child left heap is equal to 2 times parent heap, 2 times 0 plus 1, right heap 2 times 0, 0 plus 2. And then we will look into the while loop. So this while loop is used to heapify back the element. So the condition of this while loop is the index value of the child left heap or the child right heap must be less than the value of the size heap. So in this case, the value is 6, and the value of the parent heap must be less than the value of the either one of the child, either left or right. So it satisfies both of the conditions. The value of the index value of the child right and or child right heap is less than the size of the heap, and value of 7 here is less than 8 or 9. In my program, if the value of the child, I will compare first the value of both of the child. If the value of the right child is greater than the value of the left child, we will do this process. If not, we will do this one. So in this case, since the value of the right child is greater than the value of the left child, so we do the same thing. Temp equals to parent heap equal to child right heap equal to temp. So we declare temp equal to 7, and then the parent heap will be equal to 9, and then the child right heap here will take the value of the temp right now, 7. Next we will update the value of the index over here. So right now the parent heap will point to this value, parent heap, and then we'll calculate based on the value of the value of the child left heap and the child right heap. Basically the same stuff, 2 times parent heap plus 1, 2 times parent heap plus 2. So over here, 2 times 2 plus 1, 5, 2 times 2 plus 2, 6. But since it doesn't really have the value over here, so we'll just ignore it. But since in this case the value of the 7 is greater than 3, so it will stop right here. And then for the final, there are 4 final functions in my class heap. First one is for the generating random numbers. In this case, I will generate 9 random numbers, and after each of the value is created, I will enqueue to the heap, and then I will heapify it. So this is just basically a function to show the heap, and this is to check whether we have 9 or more random numbers, because in the requirements we have to have at least 9 numbers to be sorted, and this empty here is just to check whether the priority queue is empty or not. So now let's have a look